Hello, geometry. Welcome to lesson 8.4 on the law of cosines. We learned about the law of sines in the last lesson. Today we're going to learn about the law of cosines. And again, remember that these ideas, these laws are obeyed so that we can solve non-right triangles. Right? That's why they're so helpful. Okay? So let's take a look at what the law of cosines is. Let's actually build it using some clever algebra. All right, so it says triangle ABC is not a right triangle. Again, non-right triangles. Can you use a cosine ratio to write an equation relating the side lengths of A, B, and C? All right, so again, here's my triangle. Angle A, opposite side A, B, B, C, C. We're going to draw that same height we draw in last lesson from A down. It's an altitude. It's perpendicular, so it creates two right triangles. We're going to call it H. Now, here's the difference between the law of sines, the law of cosines. We're going to use this side of A. We're going to call this little snippet of it X in this small right triangle. So then over here, from B to where the altitude hits the side BC, we're going to call this A minus X. And again, the reason we call it A minus X is because the whole thing is A. Right? This whole thing is A, and we're calling this piece X. So that is what's left over, A minus X. And now we're going to apply two familiar rules. First is the cosine rule, right? So we're going to take the cosine of this angle C here. So cosine of C equals, so cosine is adjacent over hypotenuse. So the adjacent side to this C would be the X. And the hypotenuse would be B. Now we're going to see this B, this X, somewhere else in the next formula we use. So I'm going to get X by itself by multiplying both sides by B. Similar to what we did with the H using the sine, right? So this is going to be B cosine of C equals X. And again, we're going to hold off to that till later. The second thing we're going to do is we're going to use Pythagorean theorem with this triangle on the left, right? Pythagorean theorem, A squared. I'm sorry. We're going to do Pythagorean theorem with the triangle on the right. Okay, so I apologize. We're going to do three things, right? We did the cosine. Now we're going to do two Pythagorean theorems. So let's do the Pythagorean theorem with the triangle on the right. So let's let X be A, so X squared. Let's let H be B plus H squared. And then, this is confusing, but B is our hypotenuse. So that will be by itself equals B squared. Okay. All right, and then thirdly, let's do Pythagorean theorem with this triangle on the left-hand side. So let's let A minus X be the first leg A. Remember, squared it. Notice I put in parentheses. Let's let H be the second leg H squared, and that's going to equal the hypotenuse, which is C squared. I'm going to go ahead and multiply this out. So you either know that A minus X squared is A minus X times A minus X, and you do the distribution, right? Or if you know the rule, that it's going to be A squared, it's minus 2 times the product, right? So we take A times X, that's AX, and we put 2 of them. And again, the idea is that when you distribute, you would get negative AX, and then, sorry about that, you get negative 8x from the outside product, and you get negative ax from the inside product. That's 2 negative ax's. And then you would square the negative x to get positive x squared. Okay, so that's how that expands. And again, you could do the distribution up here if you want to. Again, a to ax, negative x to a, negative x to negative x. You'd get the same thing. Bring down the h squared and bring down the equals c squared. And now I'm looking for some similarities between what I see over here in red and blue and what I see over here in green. So the first thing I see is I see this x right here and this x right here. We're going to replace this x with a b cosine of c. So we're going to have a squared minus 2a and then b cosine c. And then I also see this plus x squared h squared right here. So in place of that, we're going to put a plus b squared equals c squared. And I'm going to rearrange this. I'm going to connect the a squared and b squared together. A squared plus b squared minus 2ab cosine c equals c squared. And this is going to be the law of cosines as you know it. Now the law of cosines, it's actually written backwards. So the c squared comes first. I won't look like that. Never mind. So the c squared comes first, and you'll see on the next slide. But this is what we're going to end with. This big, long law of cosines. Now notice, it's very similar to Pythagorean theorem, right? A squared plus B squared equals C squared. But then there's this like minus 2AB cosine C. That's like the law of cosines part, the non-right triangle part that you have to remember. Okay? So there we go. All right, so now you'll see the formal introduction on the next slide here. So here is the law of cosines. So for the law of cosines, it would be whatever side you have isolated over here, right? So like a squared here, the angle opposite is in the cosine. So because this is a squared, then you have cosine of a there. And again, notice the b and the c here are also used there, bc. And again, same thing. B squared here, so then cosine of B, and C squared here, so cosine of C. So again, whatever the side by itself is, the isolated side, that's the angle that goes inside the cosine. Now notice in this formula, you have to use the three sides and an angle, right? So your two choices are side, side, side. If you have side, 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 that means you can fill in lowercase a, b, and c, and you're solving for the angle. Or you can use it for side, angle, side. And with side angle side, you would have the whole right side. For instance, down here you'd have A and B, and you'd have angle C, because C would be in between A and B, and you could just solve for side C. These are the two cases you would use for the law of cosines. Now, the one thing I will mention right here with side, side, side is that you need to find, okay, you need to find the largest angle first. Find the largest angle first. So notice that, or understand that the largest angle is opposite of the longest side. But the idea is that when you have to find an angle, you're going to have to use what's called the inverse cosine. All right? And the inverse cosine, this is a lot of pre-calc talk, but the inverse cosine has a range between 0 and 180. So if the angle, the largest angle, is obtuse, you will get it by using the inverse cosine. So again, this is for another day. Again, you'll talk more about it when you take pre-calc and trig, but just for today, right, when you use the law of cosines, if you have a choice, find the largest angle first. And there you go. All right, cool. All right, so let's do one of these problems, and then we'll, there's going to be two videos, so we'll do the first problem on this first video here. So it says, what is BC to the nearest 10? So again, we're not going to just find BC, we're going to solve the triangle. So again, you're going to see that a lot in your problems today, so let's solve the triangle. That means, again, we want to know what angle A is, what angle B is, what angle C is, what side A is, what side B is, what side C is. So right now we know angle A is 57 degrees. We know that side, that's A, side B is 10, and we know that side C is 8. Right? So this is the side, angle, side case, right? So this is a law of sines situation. Now, when you use the law of law of cosines, this is a law of cosines situation. I apologize. When you use the law of cosines, typically there's only one way to start, right? So this problem here, you have side C, you have side B, and have angle A. Since you have angle A, you have to find side A first. So our formula will be A squared equals, all right, think of it like Pythagorean theorem, B squared plus C squared. And then here comes the law of cosines like fixer, minus 2BC cosine of A. Remember, A here, A there, B and C here, so BC there. So I don't know what A is, so leave it alone. A squared equals, B is 10, plus C is 8 squared, minus 2 times 10 times 8 cosine of 57 degrees. And understand that once you get this number, to get A squared by itself, to get A by itself, you have to take the square root. So if you want to type this in all at once with the square root, that's fine. You could also type in what's inside the square root, then do that second answer. It's all up to you. And I'm going to round this to 2 decimals because, again, we're trying to solve the triangle a little further. I'm going to show you in Desmos how to do this. Okay, so this is going to disappear. Okay, so let's go to Desmos. Let's remember that when you go to Desmos, you have to change the wrench, right? The wrench puts it in degree mode. Make sure you do that. Okay, so I'm going to do the square root. And now we're doing 10 squared plus 8 squared. All this is inside the square root. Minus 2 times 10 times 8 cosine of 57. And there's my length of A, 8.77. So A, which is also BC, which is the answer they want. So A is 8.77. Okay, all right, so let's go back to our problem. So we now know that A, which is right here, is 8.77. B is still 10, C is still 8. So now, what can we find next? Well, now we have all three sides in an angle. It would be great to do law of sines, and we could, but here's the problem, right? We don't know the largest angle yet, right? We know that the largest angle is going to be B, because it's across from the longest side, 10. If we use law of sines, and this is an obtuse triangle, the law of sines will not give us the correct angle B, because inverse sine does not act like inverse cosine. We have to use law of cosines again to find angle B. To do that, we're going to use side C, side A, side B, and then angle B in the law of cosines, which means it's going to look like this. B squared, because angle B is our angle, equals A squared plus C squared minus 2AC cosine of B. So I know that B is 10, so 10 squared equals, I know that C is 8 squared, I'm sorry, that's A. Again, I can't read my own writing. That's A squared. So A is 8.77 squared. Again, it's annoying to have the decimals, but it'll make us have the best answer, closest approximation. Plus 8 squared minus 2 times 8.77 times 8 cosine of B. So here's how we're going to handle this, right? There are three parts. The 10 squared, the 8.77 squared plus 8 squared, and the negative 2 times 8.77 times 8. This right here cannot be combined. And that is because this term right here is connected to the cosine of B. Right? These are not like terms because this has a cosine of B and has a variable. These ones don't. So we're going to do three parts. So 10 squared is 100. 8.77 squared plus 8 squared is going to give you 140.9129. And again, I will leave it out. It's annoying, I know, but I'm going to. Minus, so then we'll do 2 times 8.77 times 8. And we get 140.32. That's a little bit better. Cosine of B. So now I'm going to move the 140.9129 to the left-hand side. So subtract 140.9129. Subtract 140.9129. So 100 minus 140.9129 is negative 40.9129. That equals negative 140.32 cosine of B. And then I need to divide by negative 140.32. Divide by negative 140.32. And I'm not going to do that. I'm just going to know that the negatives will cancel. So now I have that the cosine of B equals 40.9129 over 140.32. And now to get B outside of the cosine, we have to use the inverse cosine. To find the measure of angle B, we take the inverse cosine of this answer. So I'm going to plug that in and get that answer, and then I'm going to type it right in there. Okay? And I'm going to show you. 40.9129. Okay, so let's go to Desmos. So up here, cancel. I'm going to do, what is it? 40.9129 divided by 140.32. And then I'm just going to copy and paste that. So then I'm going to do inverse cosine And I'm going to copy and paste this. Control C, Control V. There we go. And there's the angle measure I get, 73.0, and we'll go ahead and just call it 73. So now the measure of angle B, which is what we just having, is 73 degrees. Now, of course, it's not obtuse, right? So this was not an obtuse triangle. All right, but again, if it was obtuse, you would have gotten the correct angle measure. And now to find the missing angle, angle C, we're going to add angle A and angle B to get 130. We're going to subtract that from 180 to get 50 degrees. So the answer to our problem, so again, I'm going to use capital letters for the angles to be lazy. So angle A is 57 degrees, angle B was 73 degrees, angle C was 50 degrees. And then the measure of side A we found to be 8.77. The B was given to us as 10, and C was given to us as 8. And that would be solving the triangle. All right, great. I'm going to stop the video now. We have 2 more questions to do on the next video. All right, here it comes.